So Doug Tipple's original plans called for the embouchure hole to be 525 millimeters from the end of the flute, but that was using that 3/8 hole. I'm at about 544 to the center of the embouchure hole, and that's because I'm using that larger, it ends up being a little larger than 7/16. And then I'm getting ready to lay out the finger holes, and there's different tastes on finger holes. I know some guys like them all to be perfectly straight down the center. I find it more comfortable if they're offset. Whenever you're drilling the finger holes, a difference of 1 millimeter makes a difference. If it's a millimeter too far that way, it will require a, let's see, a smaller hole. And if it's down towards the open end, it will require a bigger hole. And then if they are not lined up like side to side, it affects how far around you have to place your fingers, you know. So Doug Tipple calls for a distance of 98 millimeters from the beginning to the first finger hole. So I've gone ahead and marked that center line, and then the way that I like to determine how far forward and backwards they go, I get my fingers generally lined up with the correct distance with the hash mark that I made. And then I just kind of wiggle around and find where it's comfortable. And then I draw where my finger is, because that's a nice comfortable position. So then I can see there's the end. So it just needs to shift. I want it to be like in the middle of my finger contact patch. So it just needs to shift a little bit to this side. So on this first Tipple flute that I made and played at church, I marked center line with tape, and the right hand, they are offset about 3 millimeters to the back side, and the left hand is offset about 3 millimeters to the front. So there's a 6 millimeter split between these two. That's just me. You probably have to find what's comfortable for you. All right, I'm set up and ready to drill. Double check my location. I always start really small, and I work my way up, normally 1 drill bit size at a time, because I don't want to go too big and ruin the flute, and now it's too sharp. And so I go really slow on this, and I test it in between every single drill bit size, and that takes a long time. All right, it needs cleaned up and undercut. It always sounds really nasty until I get it cleaned up and sanded up. And then once the hole is nice and pretty, it sounds pretty as well. For undercutting, this is the file that I use. Really little guy, and it's flat on the back side. That doesn't matter. Actually, it does kind of matter, because if it's flat, you can lean it over a little bit further. You want to make sure you're not scarring up the top side of the hole whenever you're undercutting. And this is slow work with a hand file, but rotary tools work way too fast for my comfort zone for this job. So I spend probably a minute on each hole with a hand file. You're not going to be able to see down the tube, probably, but whenever you undercut this, there's always some plasticky hair that I go in and clean out with some rolled up sandpaper. So all right, let's check the intonation. That's pretty good. All right, I'm not going to show drilling every hole, but here is my notes that I got from Doug Tipple's website. So, okay, this is a last minute addition. So yesterday at church, I was asked to play a song in the key of F, and then it modulates to F sharp, and then it modulates again to G. So I'm gonna start putting I did this twice yesterday. I did one experiment run, and then I did one good quality Putting a thumb hole here allows you to play an F natural, and it allows you to play in the F major scale. So I'm just marking where I want that thumb hole to be. So I line it up with that is an E hole, and it doesn't go 100% on the bottom in accordance with where it's comfortable for my thumb. So I'm just figuring out the location of where that hole needs to be. So it's going to be in line with that E hole, and then right there. And that is not quite 180 degrees out. It's not all the way down on the bottom. So that allows me to play in F major. So that song I can play in F major, and then when it transitions to F sharp, I can play the 1, the 4, and the 5, and that'll get me close enough until it modulates up to G, and then you can just play in G. So I'm going to start including an F hole on all of my flutes now, I think. Okay, for this F hole, I got it drilled and I got it tuned. I don't have it finished yet though, so I always double check the bottom D to make sure my embouchure is all right. Then check the F. It's a touch flat. Because this hole is so tiny, very small holes like that, they cause the air to just go screaming out of it. At least that's what I understand to happen. And it adds a lot of breathiness and raspiness to the sound. So a good way to help with that is undercutting. And the really good thing is that we have access to the inside of that hole from the E hole. So the sidewall on this 480 PSI Schedule 40 is really thick. So it calls for, in my opinion, it calls for a rotary tool. Be very careful. I've got the chamfer pretty well finished up in there. The GoPro doesn't focus, but I'm hoping you can see that. I also put a little bit of a chamfer over here on this side, because as you're playing and you want to uncover that hole, just slide your thumb over. Rather than taking your thumb off, because you still want to maintain control of the instrument, obviously. That's from 1 to a 3 flat. That's a minor third. I always think of the Hans Zimmer Dark Knight track. Bum, bum. He uses that in a lot of his soundtrack writings. All right, for this next part, I want to make a little bit of an illustration, because let's say you're looking down the bore of the flute like this. This is a cross section, and the embouchure hole is like right here. That's probably not quite big enough. And then that's undercut though, right? And then as the air comes in, it goes down. Half of it goes down. Half of it hits and goes up. And then this air that's running down the inside of this tube, it hits the wedge. Let's say the wedge is right there. This is obviously all perfectly to scale. I'm just kidding. It's not to scale at all. As the air comes down, boom, it hits this edge here. That's why, I don't know if I mentioned this or not, you could undercut this or chamfer the edge of that. I think that would work, but you're never going to have a perfectly good seal down here at this corner. So my idea, I've done this on all of the flutes that I've put wedges in so far. Let me clear up this drawing space a little bit. So I'm going to take some JB Weld, that is epoxy resin filler basically, and I'm going to fill this in so it's a nice smooth curve. I will do that on both sides, and then the air can just kind of streamline around it. Before I was putting JB Weld, it had a lot harsher, more gaspy, airy, breathy kind of a tone. Since I've started doing this, they sound a lot cleaner and smoother. And then I take sandpaper. Where's my sandpaper roll? I take this and I stick it in the bore and clean knock off all the high points, and that actually chamfers these edges a little bit too, so it makes a nice clean transition for the air. So I'll do my best. You got a working time of about 15 minutes depending on the temperature and how you mix this JB Weld up. So you want to get it on the end of the popsicle stick. Yeah, I'm not going to be able to get it. Reach it down in there, drop it into the place on the far side, and then scrape it back towards you. So I'm not capturing that on camera, am I? So what you want to do is fill in that little trough, that little valley. Now, it's not really going to be a perfect job using just the popsicle stick, but I have to end up sticking my fingers down in there as well. So if you're going to do that, wear gloves. If you're going to sand, wear a respirator. If you're going to use a drill, wear safety glasses, do all this stuff. Don't do what I do. All right, so now that the JB Weld is dry, I'm going to go in there with some sandpaper. I'm going to start with 100 grit to cut it up pretty good. The frequency of this light is not conducive to matching up with the camera, but I think you can see the cross section there. There's the embouchure hole clocked up to 12 o'clock now. Let me get the GoPro back on so I can see if I'm in there. There we go. So you can see where the air comes in at the embouchure up here, and it would have a nice smooth path to travel around as it circles inside the bore. And the JB Weld doesn't run the full length of the wedge. I'm only able to get it in there, 4 or 5 inches from the opening, and that seems to be perfectly fine. And that seems to give it a lot cleaner, sharper. By sharper, I mean a more acute sound than whenever the air can go in there and hit the edge of that wedge.